welcome to Cruising the Cosmos. I am Joshua Laughlin.
And I'm Jason.
Tonight's episode, the Solar System, our home in the cosmos.
Josh, what is a solar system?
Well, Jason, that's a good question. Now, when referring to the solar system, they're referring to our solar system. And that's because another name for our sun is Sol, which is based in Roman mythology. But a solar system is one or more stars that have bodies orbiting it, planets.
Alright, so our solar system is based on our star, the sun. We have some planets around it. What can you tell me about these planets?
Well, we have 8.
8?
8 planets. My very educated mother just served us 9.
9?
9!
9 what?
Well, it used to be pizzas. It used to be pies, but now it's nothing.
Nothing?
Nothing.
No pizzas or pies?
No pizzas or pies.
What do you mean?
It's gone.
What's gone?
Pluto.
Pluto?
In 2006, they dismissed him as a planet.
Surely you jest.
I do not. It's gone.
Gone?
All gone.
No pizzas or pies?
No pizzas or pies.
Bunch of savages in this town. So now we have our solar system.
Yes.
We know that a solar system is a sun or a star, which in our case, our star is the sun. We have some rocky bodies or some gaseous bodies, which are our planets, in our case. Josh, can you show me what that looks like?
I can, Jason. In fact, we have this.
What is that?
It's a model of the solar system. It's moving.
Really?
Fine.
Ooh.
You like that? It's a scale of our solar system.
That's nice.
I'm glad you approve.
Well, thank you. I appreciate that. So, so now we know what our planets look like. You know what happens with them. What's the names of our planets? What do we got on that?
Well, we have Mercury, Venus, Earth, and Mars, part of the inner solar system. Those are the rocky planets.
Mm-hmm.
Beyond that, we have Jupiter, Saturn, Uranus, and Neptune. Those consist of the 8 planets in the solar system.
Okay, so that's our 8 planets. So again, now we have our sun, which is our star. We have our 8 planets. Tell me, what else can we find in the solar system?
Well, in between Mars and Jupiter, we have the asteroid belt. Now, in that asteroid belt, we have another dwarf planet called Ceres. It used to be just an asteroid, but since the declassification of Pluto, we now have these dwarf planets.
Dwarf planets, huh?
Dwarf planets.
There's a couple of those hanging around, right?
There's a few.
Okay. Well, about how big would a dwarf planet be?
Well, we got this one.
Well, I've seen bigger.
I'm sure you have. I digress.
You do. So now that we know we've got our sun, which is our star, we have our planets, we have an asteroid belt in between. What else is stuffed in our solar system?
Well, besides the asteroid belt, once you get further out, you get past Neptune, you have the Kuiper belt,
Okay.
which we now say that Pluto's a Kuiper belt object.
Okay.
Now, even further out, you have the Heliosphere,
All right.
which is the solar winds, the hot plasma, creates a nice protective bubble around us. Even further out, you have the Oort cloud, and that's where we believe a lot of our long-term comets come from.
All right.
Now, even further out is where you find the Heliopause. Now, that's where the interstellar medium and the pressure from our solar system, they kind of collide together.
Gotcha. Well, that's kind of neat.
Pretty much.
I guess that about sums up a solar system, huh?
Well, it gives you at least a taste for it.
How many moons are in the solar system? Is it A, 700, B, 1000, C, 900, or D, 140? Your answer later in the show.
So we've talked about a solar system, Josh. I've heard a couple different terms for systems. Tell me, what other kind of systems do we have out there?
Well, for the broad term, when someone says solar systems, what they're referring to are planetary systems.
Okay.
And that just encompasses any, solar system that isn't ours. It's out there in the universe, out there in the galaxy.
Okay. And heard something about a star system.
Well, see, that's something very different. A star system is basically stars, and they're gravitationally locked to each other, and they orbit each other, and that's where you get your clusters, star clusters.
Well, that's easy enough. What just out of curiosity, what would a nice star cluster look like?
Well, of course, I can give you this one.
Nice.
Indeed.
So another little question here: how do we get to where we're at? How does a solar system form?
Well, Jason, it starts with gas.
You don't say.
I do say, and lots of it.
Ooh, do go on.
Well, in the Big Bang, created lots of hydrogen gas. Well, that gas forms your nebulas, your large molecular clouds. And these clouds, once gravity takes hold, it starts compressing that gas down. It gets hotter, starts to spin, and once it gets to just that right temperature, it ignites. And it creates the solar winds, blows off all the remaining debris. And what you're left with is basically some rocks, some gases here and there, orbiting that star. Over a very long process, create your planets.
Well, I can imagine that takes a very long time, considering that we started out as basically dust and got ourselves on this big rocky ball over here.
Indeed.
So we kind of know our solar system's fairly old, but where are we at in terms of stellar evolution?
Well, we're middle age. Our solar system is roughly about 4.5 billion years old. Another 4 billion years, our sun's going to start to die. It's going to become a red giant. At that point, the hydrogen is gone. It's going to be burning its helium. It's going to cause it to expand, and when it does, it's going to probably engulf the Earth.
Oh, that doesn't sound good.
No, it doesn't. It's going to get hot.
Huh.
Yeah. So after that, it's going to blow off its outer layers, become a planetary nebula, and what's going to be left at the core is a white dwarf.
Well, that's pretty neat. Planetary Nebula, huh?
Hey.
That's universe kind of recycles itself, right?
That it does. Eventually, the nebulas, they can form the larger clouds, and once again, it starts the process all over and creates new stars. In fact, the Orion Nebula is one of the most well-studied star factories.
What's it look like?
Jason, it looks like this.
Impressive.
I agree.
Your answer to the cosmic trivia question is D, 140.
So, Josh, today we talked about our solar system, talked about planetary systems, which are pretty much the same as our solar system. We discussed a little about star systems, but not too much to touch on here at the moment.
No.
We discussed about, like I said, planetary systems. Said we've discovered 713 planetary systems so far.
Indeed.
144 of those are multi-planetary systems.
Yes, sir.
That's a lot.
Yes, it is.
That's a lot more than what I thought.
I have to agree with you on that one.
So with that in mind, is there anything else that you'd like to discuss?
Well, there is, and I want to put things in perspective for everyone. And to do that, I'm going to have to give you a few definitions.
Okay.
To start off with is astronomical units. That'd be AUs. And that's the distance between the Sun and the Earth, which is 93 million miles. Now, from the Sun to the Oort cloud, which is the furthest physical object in our solar system, you're looking at around 50,000 AUs. So it just gives you a scale of how large.
That's a pretty big number.
Yeah, that's pretty large. However, it gets even larger. So let's say to the nearest star.
Okay.
You're looking at around 271,000 AUs.
That's going to be a long time to travel to escape this doomed planet.
Yes, it is. It's going to take a long time. But when we're using a outside the solar system. We're not going to really use AUs anymore.
Okay.
The numbers just start getting way too large. So when you're dealing with those kind of terms, we switch over to light years.
All right.
Light year has been misunderstood. They think it's a unit of time. Years, time. No. It's actually length. It's
How far light travels in a year?
exactly. How else to describe it? That's the measurement it is.
Mm-hmm.
So 1 light year is 6 trillion miles.
More or less.
Roughly.
Yes.
Now to our nearest star, Alpha Centauri, you're looking at approximately 4 light years.
Well, that's a little bit better than 271,000 astronomical units.
Indeed it is.
My pen and paper will be much happy calculating that.
Well, I mean, it just goes to show. I mean, when you want to make things a little bit easier, so we use, different numbers.
Mm-hmm.
I mean, imagine trying to get the how large a galaxy is using AUs.
While it would be fun, I don't think I'd want to try it.
Nor I. I think we'll stick with light years.
I would agree. So, we talked a little about astronomical units.
Mhm.
We talked some about light years. Both are very important for your foundation in astronomy.
Very.
So, with that being said, it's on to the news.
All right. So, some interesting things have happened since we've been gone. Something I thought was really awesome was we froze light.
Yeah, but it was only for like a minute, man. Wake me up when it was an hour.
Well, if you don't like that, maybe you'll like this.
Ooh.
This is Earth, seen from the Cassini probe that's orbiting Saturn.
Nice.
It turned its gaze onto us, that pale blue dot, Earth.
We waved, and we got a certificate.
Oh yeah. It happened.
It did.
Well, I wanted to thank everyone for joining us and watching Cruising the Cosmos. I hope you enjoyed yourself learning about the solar system. So, Jason, could you get our schedule for us, please?
Sure, absolutely. Let's see what we have. Josh, it looks like our next show is Saturday the 10th.
Sounds great. I hope to see you all on Saturday the 10th.
Hey, Josh,
Huh.
do you see this? Pluto's not a planet anymore.
Next time on Cruising the Cosmos.
Dude, why'd you flip the coffee table? And you're gonna have to pay for that lamp, man.